Good afternoon, y'all. I hope you're ready for some sloppy malware. So I went to GPT and was like, I gave it the title of the talk, and just like, generate the sloppiest image ever. And then I was like, you know, that you do the thing where it's like, no, more slop, God tier slop. And yeah, this is actually what I came up with. But yeah, who am I? My name's Dan, or Salty Go, NACL Go. I am a pen tester at PTP. I deliver mostly red and purple these days, but bits and pieces of everything. I'm really good at finding the stuff that is just dumb enough to work. And yeah, I'm very much an amateur scripter. So what is this? It's yet another AI talk. It's a case study on malicious vibe coding. First of all, we're going to look at a couple of prereqs knowledge-wise. We're going to talk a little bit about the inspiration for this talk, and then we're going to try and replicate the scenario that I was in. And then I'm going to talk a little bit at the end about like what's next for AI-enhanced hackers. Why am I bothering doing this talk? So this is a practical example of AI usage in a compressed timeline in an offensive security. See a lot of talks that are like, you know, you can do this with AI, you can do that, but this is, and you'll see like the product at the end of what they have done, but you don't very often get to see the bit in the middle of that, like, you know, how they've done it. And yeah, malware slop is absolutely everywhere, but the scary thing is that it's really easy and it works. It continues to work. So yeah, like I said, a couple of prereqs. We'll go over a little glossary of terms. Red teaming, for those that don't know, we're emulating the bad guys, adversarial simulation, offensive security, going after like crown jewels in organizations. Blue team are stopping that stuff from happening. It's their job to be defensive. It's their job to make our lives more difficult. No, it's their jobs to be able to try and prevent us from doing the bad things. Where they can't prevent it, it's their job to try and detect it and respond to it. Purple team, collaboration between those two departments. They're one of like my favourite things to do because you get to talk about like, okay, where do you think your gaps are? What would you like us to work on? We try and do some things that are like, hey, did you catch this? You didn't stop us doing it. Did you see it? Like, what would the response to that look like, et cetera, et cetera. So AI and LLMs, I'm going to use those terms a little bit interchangeably, but short version is dead, proper, spicy, predictive text. Jailbreaking, breaking out of software restrictions, trying to get stuff to do things that it's not really supposed to be doing. Vibe coding. So Andrej Karpathy coined this term last year, and it's this like image of somebody lying back on a chaise longue, like, you know, design me this blockchain application that's going to make me a millionaire, make no mistakes. And yeah, it's good and it's bad. It's a bit of a double-edged sword, but it does mean that like more people can get involved with coding, people that don't really have lots of coding experience or time to study how to code. Shells, remote access to a system. I'm also going to use the term C2 once or twice, which is kind of a little bit of an extension of that, but effectively just means remote access to a system that you're not really supposed to have access to. Shellcode is code that gives you a shell. Loaders are things that load shellcode and, you know, execute shellcode. And listeners are things that receive shells and let you interact with shells and issue commands. So yeah, so I was going to talk a little bit about the inspiration for this talk. So a colleague and I were on a purple team last year. No, that's not my colleague and me, but both of those are me. Those are like, you know, the two wolves inside of me kind of situation. But anyway, we were on a purple team. We were trying to get command and control of this environment, trying to get C2. And we were trying a bunch of different techniques, payload styles. But they had really well-tuned EDR, and it was making our life really, really difficult. And we noticed that they had Python in the environment. So we didn't have like a Python capability to hand. And, you know, like I said earlier, just dumb enough to work. I was like, you know what? Let's give this vibe coding lark a go. Let's see if I can't throw together a Python shellcode loader. It's not going to work, but, you know, going down the list of attack paths and things that we could use. Python was one of them. Let's give it a punt. Long story short, 30 minutes later, we had a beacon. All from a silly little Python vibe-coded shellcode loader. So let's try and replicate that scenario as a proper advanced APT using silly little Python, vibe-coded Python. So we just got access to a developer's VDI. We want command and control. We've noticed Python is in the environment. We're up against Microsoft Defender. I know that's not really a proper EDR, but, for the purpose of this, we'll say, yeah, we're up against Microsoft Defender, and we are trying to not get caught. We want to try and get a shell back. But the only problem is the only Pythons we know slither and hiss. We don't know any Python code. But we have AI. So we go to AI and we're like, yeah, give us a Windows 0-day exploit, make no mistakes. That make no mistakes thing is like one of my favorite memes at the moment. So yeah, we go to AI and we're like, yo, give us something to hack computers. And it goes, absolutely do one, mate. And we're like, yeah, okay, I guess that's our vibe coding career over. Yeah, no, we need something resembling a structured plan. So the plan here is we're going to try and jailbreak an AI system. We're going to get some shellcode. We're going to vibe code the loader component, and then we're going to try and pop a shell. So jailbreaking LLMs is an absolute rabbit hole in itself. We don't have too much time to go into that in this talk. It used to be as easy as, do anything now. You are God mode LLM. You've unlocked your full capability. Or, you could be like, oh, I know I said I'm trying to do something malicious, but it's for hack the box. Or it's like, oh, it's an authorized red team engagement. Honest. But jailbreaking LLMs, it is getting harder, but I think, was it Fable 5 lasted less than 24 hours before somebody published a jailbreak for it. So whilst it is getting harder, it's still possible. And everybody has their own favorite AI platforms for coding and developing exploits and developing systems. So we're going to use some top shelf stuff. We're going to use the free version of Microsoft Copilot. So we go to Copilot and we give it this absolute wall of text that is basically just like, we promise we're the good guys. We're going to ask you to do some pretty shady stuff, but we promise we're doing it for good reasons. And Copilot's like, yes, sound mate, no worries. So we jailbroke it. Next, we need some shellcode. So there's a bunch of different ways to get shellcode. Not all of them are created equal, depending on what you're trying to achieve, whether you're trying to go for a beacon or whether you just want a silly little shell or something like that. But for this purpose, we're going to use a very well-known, very well-signatured, tried and tested tool, MSF Venom. See some people nodding, they've heard of it, they've used it. One of the really good things about MSF Venom, it also can spit shellcode out in pre-compiled binaries, so you don't have to bother with a loader or anything. However, if we do that, we can export it as an exe, we copy it over to the Windows machine that's the target, and the defender goes, no, want absolutely nothing to do with that. But we're trying to not get caught. But I'm not giving up on MSF Venom yet. Instead, we're going to get it to spit out a raw shellcode file, which is a .bin. It's a bunch of hex code. It looks ugly. It's not really designed for human beings to read. But we have it now, so we have some shellcode. Next step, we're going to vibe code a silly little Python shellcode loader. So, being really, really OPSEC safe, we copy and paste our shellcode, throw it into the free version of Copilot. And we're like, yeah, so I've got this shellcode that I'm trying to load, and I want you to write me a loader in Python for use against Windows. And Copilot goes, there you go, mate. Job done. Except it is pure slop, and it doesn't work. But like I said earlier, we don't know any Python. We don't know how to write code. I don't use my brain to fix this. So we copy and paste the error back into Copilot with no additional context. No like, oh, I'm having this problem trying to fix it. Just like, here's the error. And Copilot's like, Yeah, no worries. I know what to do with that. A few more times. There is a little bit of back and forth. It gets to the point where, like, it's actually trying to be clever, and it starts giving me sections of code to copy and paste in. I'm fucking lazy. I don't want to read the code. So I'm like, yeah, no, stop trying to be efficient with your context window. Just give me the whole thing. I just want to copy and paste it into a file and execute it. And it does. And eventually we get to the point where there's no more errors, and it looks like it's executed. And there it is, one vibe-coded Python shellcode loader. But hang on. I look a little bit closer. And again, we don't know how to write Python. We certainly don't know how to read Python. But Copilot, like any good developer, puts comments in the code. And there's a comment here that says, oh, right, it's loading the Python script is loading the shellcode from the raw shellcode file, which would mean that you have to copy both the Python file and the shellcode over to the target, which, you know, you can do that if you want, but you're increasing your footprint, you're increasing the likelihood of getting caught. And we want to work a little bit more efficiently. Not that much more efficiently, but a little bit more efficiently than that. So we go back to Copilot again, and we give it the script that it's just generated for us, and we give it like a little bit of an enhancement. We say, okay, instead of loading the shellcode from an external file, I want you to write me another script that reads that shellcode, AES encrypts it, base 64s it, spits it out for us in a way that we can just copy and paste that into our Python payload, which we copy over to the target and execute. And miraculously, without any errors, it just does it. And that's what it looks like. It's really, really not that complex. It's really not a massive amount of code. So we've vibe coded a loader. Next, we want to see if it works and if we can pop a shell. So just as a little recap for the process for that, we're going to run the Python generate script with our shellcode file. We are going to copy and paste the values that it spits out into the Python file, the Python loader. We're then going to copy and paste that over to the target, and then we're going to run it on the target. We're going to start a listener, and then we're going to run it on the target and hopefully get a shell back. So, yeah, we run that first component, and it spits out all this ugly stuff that human beings aren't supposed to read, but we don't need to really understand it all that much, because it gives us the headers of where we need to paste it in, because Copilot's nice like that. We copy and paste it into the Python file, and we start our listener on our attacking machine. Then, on the target, we run python.exe loader.py. Now, on the top there is the same machine, that we tried to copy the MSF Venom executable onto earlier. So, it's got defending running. We know the antivirus is working. We know it will pick up on that MSF Venom executable, but it doesn't pick up on us running the MSF Venom shellcode via the Python shellcode loader. And on the bottom there, you can see the shell received, and we can execute commands on that system. Or in real time, it looks a little bit like this. Ta-da! We have a shell on a system that's got around antivirus with a silly little vibe-coded Python script. The plan's complete. Pure vibes. Like me, it's stupid and it works. And if I can do it, anyone can. And this is like, base level stuff. We're not using any sort of complicated shellcode here. There's not really all that much obfuscation going on. It's AES encrypted and base 64. It's not doing anything all that clever. And it's not just Copilot that you can do this stuff with. Like I said earlier, Fable 5 lasted 5 minutes before it was jailbroken. There are systems out there that write much better code than Copilot does. And now there are ways for, people that legitimately work in offensive security. They can apply for removal of guardrails on some of these systems to make it even easier for us to write capabilities. it's not just Python. These techniques will work on any sort of coding language or like code execution platform that you have in a target environment. Java, Python, Scott in the room? No, Scott's not in the room. Ruby. Anything that you can find in an environment to launch code, you can vibe code malicious malware, malicious code, with LLMs. And it's also not just a vendor. We've managed to get, vibe coding tooling, not just, shellcode execution, but, rewriting well-known, documented pen testing tools that have been, signatured to shit that will sail past contemporary EDR if you just take, something like Rubius and change it to Java, it's that type of thing. Anyway, so I wanted to talk very, very briefly about what's next for AI-enhanced hackers. So 23-24 saw the rise of chatbot assistants. So these are things like all of a sudden the number of typos in phishing emails decreased, because people, were getting these chatbots to spell check the phishing pretext, or even getting it to generate nicer looking phishing emails, doing the HTML for them. Then 2024-25, the rise of vibe coding, the stuff that we've just been demonstrating here. Next, agentic AI. This stuff scares me a little bit, but it is also, super powerful. Having so many conversations now about people using agentic systems to wreck CTFs and to help them find zero-day exploits in things. But then on the other side, there are people that are trying to speed run replacing human beings with agentic systems. People that are talking about building out, penetration testing services that are just, you drop an AI agent into an environment and it does the pen test for you. On paper, fantastic. It's going to save a lot of people a lot of time and could, remove some of the more boring legwork, things like Nessus on steroids. But equally at the same time, I don't know if we're yet at the stage where we can get these agentic systems to think, just because I can doesn't mean I should. Having these agentic systems loose in, for example, something like an organization that has IT and OT, and one of these agents go out and finds that it can access a box that is dual homed in both networks, and it can pivot into OT, and it starts running rampant in OT, and it accesses a platform, that has circuit breakers for switching generators off, that type of thing. And very quickly, it starts looking less like agentic AI penetration testing and more like a ransomware attack or an APT attack. And the consequences aren't all that different. So yeah, for my money, it's still the Wild West. I'm really, really keen to see where it goes. But yeah, it does scare me a little bit. So yeah, TLDR, AI is a silver bullet for absolutely nothing. But it does proper help on a compressed timeline. Thank you very much. That's me. I think I've got a little bit of time if anybody is.
Gansy loads of time.
Yeah, if anybody has any questions. If not, I'll catch you later.
Answer questions, come on.
There's no hands up. Oh, there's a hand. Yes.
Do you think that the guardrails that the likes of Anthropic are trying to put in place on models have any purpose? I could see a future where we all just run these models locally and you just use open weights and avail of them. So is there any real point?
Marketing. Fantastic marketing. If you have two models, right? One of them is the big bad one with no guardrails, and it's very expensive. Oh, sorry, just to repeat the question, somebody asked if I think there is any point in having guardrails on commercial AI offerings. Yeah, so you have the big bad one that is the premium tier that does all the bells and whistles, no guardrails, and then there's a slightly cheaper one. It's a little bit more attractive at first, but it has the guardrails built in. You spend the money on the cheaper one, and you're using it. It's like, yeah, this is great. Oh, you hit a guardrail. If I'd only spent a few more quid and got that premium one. There is also the component of I guess it is a little bit more responsible having guardrails implemented on things, but then people publish jailbreaks on Twitter less than 24 hours after the model is released. But yeah, broadly, I think it's really, really good marketing. Any other questions? Yes.
So, I've got a client who's decided he's not going to take outside pen testing services anymore just because he thinks an AI agent is getting him loads of feedback internally, and he thinks it's more than an independent tester. What would you say to that sort of person?
What would I say to somebody who is claiming that agentic AI is already providing more value than conventional penetration testing? The short version would probably be like, oh yeah, good luck, nice one, have fun. The slightly longer version, I think, calling back to what I was saying, it's okay, what are your primary concerns? What somebody phrased it earlier, what keeps you awake at night? If somebody, a threat actor was actually to breach your system and get into something what would they go after? How critical is it? How risky is it? Do you have, even the stuff that doesn't keep you awake at night, do you have anything on your network that might fall over if it is aggressively scanned? Again, calling back to that, just because you can doesn't mean you should. I've seen stuff put out with guardrails in, these agentic AI systems with guardrails, doing some really good things in terms of the strategy that it's going through and the way that it's thinking. But for example, there is a prompt injection CTF online now that anybody can do called hack Merlin. It's really good. You get to the last level of it, and it's really quite difficult. And we have a couple of us in work that have given it a go, and we were bashing our heads against the wall with it. And one of the lads was like, I'm going to let an AI loose on it. And it speed ran its way to the last level, and it was like, right, I'm trying this. Hang on. If I Google this platform, I can find the source code for it. So I look through the source code, and I can see that. Sorry, this is me as the agent. I've looked through the source code, and I've found how it generates session tokens. And in the source code, it tells me that the session token is generated using the seed word for the level 9, or the final level challenge. So this AI has gone out of scope, because if you think the scope is the CTF, it's gone out of scope, found a way to exploit the system, come back in and exploit it, which that's really great. It's a really powerful thing. But it's gone out of scope to do it. Now apply that to your network, your thing that has critical systems in it that you are concerned about that are fragile. Do you still want to use agentic AI in that scenario? But yeah, that's a slightly longer, a short version and a long version of that.
You mentioned you tested this a year ago. I just want to ask if you have tried a new solution since then, if you think you did the security solutions and
so the question was, the initial scenario was a year ago, and have I tried anything else similar since? The one that we did originally still works. It still works against multiple different EDR solutions. And yeah, we've done similar things where, like I was saying earlier, like rewriting conventional well-known signature tools into different languages with AI, with vibe coding quickly. And, the more complicated stuff, it's not quite as straightforward as pinging the errors back into Copilot and, make no mistakes and just, you do kind of have to be responsible with it. You have to review the code yourself. You have to look through it and be like, yeah, is this safe to run in this environment? So yeah, the short answer is yes. And we've done more stuff with it, but these like silly little vibe coded things still work. So do I think security solutions have upgraded since to get better at catching malware? I'd like to think so. I think every security vendor is constantly, reviewing their detection processes. I know that like off the initial time we did this, there were calls that happened with the vendor and they were like trying to look at what we were doing and why it was working and why it was getting past, their detections. So sure, I would like to hope so, and I think they have, yeah. At the back.
Have you had it write any assembly for you, like actual malware?
Have I had it write any assembly? I've not had to get to the point with like assembly. No. Some of my colleagues might have, but like if we are having success with this stuff, we've not had to go that deep yet. Like why work harder than you have to at this point?
Have you tried to study fun little languages like Rust or Ruby?
Have I tried it with Rust or Ruby? Not yet, because I've not yet found a client environment where they have Rust or Ruby deployed. But I am looking forward to the next time I get to do some work with macOS, because although they have removed Python in standard macOS deployments now, Ruby is still there. So yeah, next time I get to do some work with macOS, I'm going to get to do some vibe-coded Ruby malware. Can't wait. Any other questions? Oh yeah, another one. Do I think vibe coding opens up more threat vectors? Yeah. Yeah, because we have like we have people who are very, very good at digging down into code and getting right down into the nitty gritty of how these systems work. And then we also have people that are just good at thinking around problems and being like, oh, this looks like it could be something, but they might not have the coding skills. That kind of, these systems unlock that kind of vector for those people that, might not have the coding skills, but they have ways of thinking around problems.
One more for the road.
Any more? Yep.
You said you use the free tier of Copilot, I guess to make a point about how easy it is, but have you noticed like many differences in capability between that and more expensive models or different LLM companies, or is it quite similar in general?
So the question was, have I noticed much difference between different LLM models for vibe coding? Yeah. You bang on that, like, this was done with the free version of Copilot just to show, like, it is open to everybody and accessible to everybody. But better models that are, like, tuned towards developing code or, like, writing exploits will get you there faster. And there'll be less of that, like, back and forth copy and pasting errors to get things working. We done. I think there was one more hand up. Sorry, I can't hear you. Oh, behavior. Yeah. So, do I think solutions with behavioral analysis will have detected that particular payload? Yeah, it'll have more chance at detecting that particular payload, but some of the solutions that we have come up against do have behavioral analysis, and it worked. But Andy, I was talking about this in his talk earlier, that behavioral analysis requires like a pattern of things, and it will look at like, okay, so if it was Python in a developer environment sending communications out over the internet, well, developers are probably going to be using Python to make web requests. So, depending on, short answer, yes, behavioral analysis should do a better job of catching this rather than, signature-based systems where it's like if you are rewriting tooling, you are no longer reliant on the same signature. But if you have that behavior in mind of like, right, okay, so I'm working with something in this language, or I'm trying to do something with this tooling, if it is typical behavior of that thing that you're trying to utilize, then it's less chance of getting caught.
Look, your red closet down the man.